Good morning, all of you. Good morning. Loudly, good morning. Great. So you are here. You are not sleepy just like other days. So in this particular lecture, we will try to understand the feature selection approaches. So last lecture we talked about decision tree and we solved some of the problems and we understood that how the entropy value as well as information gain is really helpful while constructing a decision tree, and we can use a better approach to split the data. Now today there are certain other techniques as well for selecting the features. So some of the approaches we will see today. So the first approach is filters. So from the filter word itself, you can understand that whenever we have a number of features, then we filter the approaches or the features and we will select the features which are most relevant for the given data set. And in that there are certain other tools as well: information gain, chi-square test, and correlation coefficient. So we already discussed in our previous classes about the correlation coefficient. For example, if you have a data set, let's say this is x-axis and other is y-axis, and we plot the data and we will try to fit a straight line, for example, and the data points which will be there, they may be very close to the straight line or far away from the straight line. So if the distance of the data point from the straight line, if it is far, then we say that this is not a best model. But if most of the data points are very close to the data points, then what we say, this is the better model, and by using that model we can do a better prediction. But if we have a thousands of data, then in that case it's very difficult to physically check how many data points are very close to the straight line and how many of them are far away. So that's why instead of relying on the visual inspection, it is better to use a technique like correlation coefficient. So that we already studied, and we know that if the value of correlation coefficient is very close to plus 1 or minus 1, then we say that this is the best fitting, right? And if that value is close to 0, then what we say, the data is scattered and there is no relationship between the variable x and y. So that's why the correlation coefficient, similar as the chi-square test, also work in the same manner. So the ultimate goal of this particular point is there are certain tools and techniques by which we can find out if there is a proper relationship between the variables, let's say x and y. And if there is any relationship between these two variables, we can go for machine learning algorithms. Now, when we talk about filtering techniques, so it's not only about only two variables x and y, there may be so many other parameters. So let's say a b c d e, these are the different parameters and they may affect your model, let's say t. So what you can do, you may be interested in finding out the relationship between a and t. You may be interested in finding out the relationship between a and t. So for each of these parameter, you will find out, let's say, the value of correlation coefficient. And the parameters for which the value of correlation coefficient is close to plus 1 or minus 1, that you will consider as a best fit, and you will consider those parameters while developing your machine learning algorithm, let's say T. And suppose if you find out the variable E for which the correlation coefficient value is close to 0. So in that case, you will not consider this parameter E. So this is how you should go ahead and filter out different parameters. So in this particular example, we can say that A, B, C, D, are having good correlation with model T, and E is not appropriately related with model T. So these are the some of the examples. Now second method is wrappers. Okay, and in that recursive feature elimination is approach is there, and genetic algorithm is also there. So the recursive feature elimination and genetic algorithm we will be discussing in upcoming units. So whatever feature selection approaches we are discussing here, you just try to understand the basic concept, and the detailed mathematics and the examples we will be discussing in upcoming units as well. Now what we do in case of wrappers, so we first of all consider all the parameters, let's say A, B, C, D, E, right? And once we consider all these parameters, you will get a model, right? And once we get the model T, then one by one we check how a particular variable affect the model. So first of all we will consider parameter A, and we will check how it is going to influence the model T, and based on that influence, that impact, we will calculate some parameter, let's say m1. That m1 represents the impact of variable A on T. Then next time what we do, we consider parameter B, and we will check how it is going to affect our model T, and whatever impact will be there, that we call it as a m2. Then similarly we go for parameter C, D, E, and every time we calculate the impact of that parameter on the model. And by using the values of M1, M2, M3, we will come to know which are the parameters which significantly affect our model T. And such parameters we will take on priority for the analysis. So this is the basic philosophy or approach of the wrappers model. Third one is hybrid approach. So when we come across a word like hybrid approach, then it's a combination of different approaches. So here when we talk about hybrid approach, then it is a combination of filtering approach and wrappers approach. Then the next type is embedded approach. In that case, decision tree is a model, and that we already discussed in our previous classes. So when we say feature selection approaches, then basically there are four types of approaches: filters, wrappers, hybrid, and embedded. Again, in that there are certain sub models as well, and based on the data, the type of analysis you wanted to do, based on that we will select. And this is just a introductory part. We are not supposed to go into the mathematical details in this particular unit, but in unit number 3 and 4 we will be going into the details. Now we will try to understand each and every method with some more explanation. Okay, so as I mentioned, filtering approach is an approach in which the features are pre-processed. So one by one we check the correlation with the model to remove the ones that are unlikely to be useful for the model. So select only the useful parameters and remove all not useful parameters. Then, for example, consider temperature, humidity, height, and noise as a four parameters. And we are interested to know how these parameters are going to affect on the student study. So, if you start your study and if the temperature of the room is very high, can you concentrate? No, difficult. If temperature is minus 10 degrees Celsius, can you concentrate? Yes, no. Humidity, again, if there is a variation in the humidity, definitely you will face problem during the study, right? Noise, definitely. Hmm. What about height?
Economics will be affected like chair
No,
and
we are not talking about the ergonomical aspect. We are just talking about, suppose your height and his height is different, right? And you are sitting comfortably with all proper ergonomical aspects, right? Comfortable. Will your height affect on your study? No, right? Because we assume that ergonomically everything is fine. So these are the four parameters, and just from just visual inspection, we understood that your height has nothing to do with your study. But all other parameters, if they vary, then they will affect on your performance, right? Similarly, if such thousands of parameters are there, then what you will do? You will filter out which are the very essential parameter. For example, temperature is one of the essential parameter. So whenever your work location is there, and if there are more number of students, proper ventilation will be provided to you. So this is how we make use of such models and take some important decisions. If temperature is minus 10, so in that case you will make an arrangement of heaters so that the appropriate 25 to 28 degree Celsius temperature will be maintained in the class, and you can comfortably study. So such type of parameter filtering, its selection and decision making is done. Again, filtering techniques are not expensive, because here what we do, we try to find out the relationship between the different variables, let's say x and y. So it's very easy. Take x variables corresponding y variables, plot the straight line or non-linear equation, and you will come to know whether the appropriate fitting is there or not. So that's why we call it as a non-expensive or cheaper, and it is cheaper than the wrappers technique that we will discuss in upcoming slide. However, they do not take into account the model being employed. So for example, for a given data set, let's say if you fit a straight line, and for the same data if you fit a second degree parabola, then this model sometimes may not provide you the best suitable approach. Based on the value of correlation coefficient, you have to decide. Model may not be in a position. So these are the some of the issues with the filtering techniques. Okay, so that is the problem. Now, how this particular machine learning algorithm works? So, first of all, you need to give input of all set of feature. For example, temperature, humidity, height, and noise. Then you need to check how these factors are affecting on the performance of the student. Then once you find out the most relevant parameters, for example temperature, humidity and noise, then for these parameters you need to develop machine learning algorithm. And once you develop that machine learning algorithm, you need to check its performance, because when we select a particular feature, for example temperature, humidity and noise, you will be entering some data. Effect of effect for, if temperature is 40 degrees Celsius, how it is going to affect on your study. If temperature is 60 degrees Celsius, how it is going to affect on your study. So these are the data points, and those data points we are entering into the model to develop machine learning algorithm. But we need to also confirm whether the model is working properly or not. If model says the student can perform very well if temperature is 80 degrees Celsius, will you believe on that model? No, right? So that's why again the performance also should be checked with some fundamental thought process. So this is how the filtering model works. Once again, briefly I repeat. So first of all, you need to select all the features. For example, these four parameters, these are the features. Then based on the filtering techniques, you need to select the best ones, let's say temperature. Then by using the data, you need to run the develop the machine learning algorithms. And then by giving some random input, you need to check whether that model is working appropriately or not. Is it clear? Okay, now we will go ahead. Now second method is wrappers. So, as we already discussed, wrapper methods are based on greedy search algorithm. So, the word greedy search algorithm is new to you. So, we will not be discussing this point here. In upcoming classes, we will be discussing. So, just understand that wrapper methods are based on greedy search algorithms, as they evaluate all possible combinations of feature. So we see that effect of A on model T, effect of B on model T, similarly effect of A and B on model T, effect of model A, B, C on T. So such type of study we do for all combinations. And after that, we select the combination that produces the best result for a specific machine learning algorithm. So temperature, humidity, then your height and other parameters we consider, and we come up with a proper model. And we can say that at X temperature with Y humidity, the student can study well. So such combination you need to find out. Again, as I already said, recursive feature elimination and genetic algorithms, these are the important approaches. Again, in previous slide we discussed that wrapper methods are expensive and filtering are not expensive. So why here I am saying it is expensive? Because consider there are 100 features, okay, and you want to study how these 100 features affect your model. So one by one you will check, so 100 iterations will be there. Again you will make a combination of two, again you will check, again you will make a combination of three, again you will check it is. So you can imagine how many combinations will be there. So practically is it possible to check, test the model for all combinations? Very difficult. So it is expensive. So this is the meaning of the word expensive in case of uh, wrappers method. Now wrappers method treats the model as a black box. It never assumes something. बऱ्याचदा काय होतं की आपण एखाद्याबद्दल ओपिनियन बनवतो की हा म्हणजे हुशार, हा म्हणजे मॉडरेट किंवा ढ, राईट. सो दॅट प्री एज्युम्शन वी मेड अँड अकॉर्डिंगली वी लुक ॲट दॅट पर्टिक्युलर स्टुडंट. But that is not the correct approach, it is a biased approach. So the good interesting thing about the wrapper method is that it considers the model as a black box, and based on the analysis it will make a decision. It will not make any primary decision based on unavailability of the information. First of all it will collect the data, test the model, and then it will believe, and it will provide you some quality score, some number, and based on that number you will come to know about the performance of that model and how it works. So, first of all, a set of features you need to find out: temperature, humidity, height, and other things. Then you need to check one by one and combination how each and every individual features are affecting on the model. Then you need to prepare the machine learning algorithm. Now again you need to go back to the features, and again with the new or updated data set you need to check the features. Again you need to go back to model and check how it is working. So again it is two fro approach, and finally you will get the machine learning model which will be providing the desired performance level. So here there are a lot of two fro approaches, and this will help you to develop a better machine learning algorithm with a desired performance level. Then these are the different types of wrappers method: step forward feature selection, step backward feature selection, and exhaustive feature selection. So we will see with some example how the basic fundamentals of step forward and step backward, or it is also called as forward chaining and backward chaining as well. So for example, you have a data set, let's say x is equal to 1 and y is equal to 2. Now, if you know x is equal to 1 and y is equal to 2, then you can calculate z. Z is equal to x plus y, so 1 plus 2 equal to 3. That you can do. And if z equal to 3, then let's say a is equal to 4. So these rules you have. So initially you have a data set. Again, along with that data set, you have some rules. If x equal to something, y is equal to something, then z equal to something. and if z equal to something, a is equal to 4. So these are the well defined rules. Then what will be the outcome of this particular rule? It will be a conclusion, that is a is equal to 4. So here x is equal to 1, y is equal to 2, then we can say that z is equal to x plus y equal to 3. And if z is equal to 3, then we know that a is equal to 4. So your conclusion is yes, a is equal to 4, because it is fulfilling the requirement, that is z equal to 3. Now, in case of forward changing, what we did, we started from the data, we applied some rules, and then we reached to the conclusion. So we are going in a forward way. And what is very important in that? Data. Without the data, you cannot use forward chaining. So data, set of rules, and you will reach to the conclusion. In backward chaining, we go in a very reverse way. First of all, you have a conclusion. Let's say a equal to 4. Then if we know a is equal to 4, then we go back and we will try to find out what will be the basic rules in order to get this conclusion, that is a equal to 4. And once we understand the rule, then we go ahead and we find out what is the data. So is it clear? And that's why the backward chainings are called as goal driven approach. So when we go for data to rule to conclusion, forward chaining. When we have a conclusion, based on that we find out the rules, and based on that we calculate the data, then it is called as backward chaining. Clear? Now we will try to compare both the things. As I mentioned, when we have some data and we make some decision, then it is called as forward chaining. Now, when we have a decision and based on the decision we want to find out the data, then it is called as backward chaining. So data to decision, forward chaining. Decision to data, backward chaining. For example, if it is raining, then we will take umbrella. So in this particular example, it is raining means there is a rain. This is the data. This is the information available with you. And based on that data, you take a decision that yes, now we need to take umbrella. So this is forward chaining. You have a data, you take some decision or you draw some conclusion. Now in case of backward chaining, if you make a decision of taking umbrella, then definitely the data will be there is a rain. So again, this is another example through that you can understand how both models works: forward approach, backward approach. And as I mentioned, in forward chaining we need data. Without data, forward chaining is not possible. So that's why they are called as data driven models. So modeling, if you require data, it is called as data driven. And in case of backward chain, we start with the conclusion. Suppose you got a fever, so conclusion is fever. Now you will investigate that if you have a covid or some viral fever or something else. That is a reverse approach, and that's why they are called as a decision driven inference. So as an engineer, you may work on forward chaining, that is called as design expert systems. Or if you are a maintenance engineer and you if you want to go to the root cause, then you can go for, or you can work as a diagnostic expert systems, right? So this is the difference between the forward chaining and backward chaining. Then hybrid approach, as I already mentioned, whenever we come across a word hybrid, means it is a combination of different approaches. And in this particular case, when we talk about hybrid feature selection approach, means we use statistical tools, for example, correlation coefficient. And along with that, we can use filtering approach. For example, let's say forward chaining. So statistical approach is one approach, forward chaining is another approach. If we are integrating together and using for the analysis, then we say it is a hybrid approach. Fine. Then embedded approach. So this method performs feature selection as a part of model training process. right? And we rightly saw the example of decision tree. What we did in decision tree, we have a set of data. Based on data, we have to make a decision how to split the data. In a class, girls and boys are there, and corresponding marks are also given to you. And the question was whether to go for data splitting based on the gender, male, boys and girls, or we should set a cutoff for the marks, and accordingly we should split the data. So that kind of decision we have to make, and the decision tree we use. And in this case, it is not required to carry out feature selection itself. We do some mathematical process, and based on the value of information gain, we make the decision. So how this particular model works? So again, first of all, you should have a set of features. So boys and girls, two features. Marks is another feature, right? So initially you will start with the feature, then you generate a set. For example, based on gender, you can think of splitting the data. So this is one set. Based on the cutoff mark, let's say 50 mark is the cutoff. Based on that, you can split the data. So this is how you can create the subset. Then when you split the data based on gender, that is boys and girls, you will develop its machine learning algorithm, and you will check its performance. And the performance indicator is information gain, that is IG value. Now for split the data based on the cutoff marks, so you will develop machine learning algorithm, and again in that case you will get information gain value, that is a performance indicator. And last lecture we saw that for the same example, when we split the data based on gender, we get the value of information gain as 1. And when we split the data based on the cutoff marks, we got the value as 0.09. And we know that higher the value of information gain, better approach to split the data. So that's why we decided to split the data based on the gender and not based on the marks. So this is how this particular model works. And again, it is a two fro process. Again and again, every time you need to train the model with the new data set, and you need to verify its performance. Okay, so in this particular lecture, what we discussed, we discussed various feature selection approaches. In that, we talked about filters, where we try to find out the relationship of different variables with our model, and we select only those variables which have strong correlation with our model, and we eliminate the parameters which are not having any correlation with our model. Second, we saw wrappers technique. In that, one by one, we checked how individual parameter is impacting our model, and that impacting indicator is denoted by M1. Similarly, next time we go with parameter B, parameter AB, then parameter ABC. So all combinations we get, and we will check how it is impacting on your model. And for each and every combination, we will find out the value of M1, M2, M3. These are the performance indicator, or they represent the impact of variable on the model. आणि ज्या पॅरामीटरचं इम्पॅक्ट जास्त असेल, those parameters we will consider, and we will ignore those are irrelevant. Then third approach is hybrid. It is a combination of filters and wrappers. And the last type is embedded approach. So these are the some of the feature selection approaches. But the question comes, only these are the only approaches? No. If you go to literature, you will come across a lot of approaches. Okay, thousands of approaches, but these are the some of the approaches that we need to understand. And once we understood the fundamentals of these approaches, slowly we can explore the different approaches.